You ready? Let's go! Period. All right, here we go.
Then that's on period.
That's on period. Let's go.
Period.
Oh, wait. Period. All right, so here we go. For the head of the snowman. So just a little real quick recap. We went out, we built the snowman. The top one had 18 inches. The body was 27 inches in diameter. The base was 36 inches in diameter. And so what we're doing right now is just for the head, right? And we're trying to figure out what is the volume of the head. And then we're going to figure out how many ounces of water are contained in the head. From that, we're going to figure out how many gallons of water are in the head. And then from that, we're going to figure out, well, how much does it weigh? Being able to use that, well, there's 128 gallons or ounces in 1 gallon. And that 1 gallon of water weighs 8.34 pounds. Okay? All right, let's go. The volume. Volume of a sphere, right, is equal to 4/3 pi. We got to figure out our R. What is our R value? Okay, so for your head, we need to know what R is. If D is equal to 18, right? Then R is equal to what? And how do we know that? What do we know about the radius versus diameter?
Please excuse this interruption, but Donald Dorsey, could you please give Leona a call? Again, Donald Dorsey, could you please give Leona a call? Thank you.
Okay, so we know that the diameter of a circle is equal to 2 radii. Okay? So it's just a diameter and the radius is cut in half. It's half of that, right? So if I can plug in D, right? Do I know D? So I know D. D is 18, right? That equals 2R. Okay? So what did we do? We substituted, right? Ladies, including you. Okay? We're gonna divide 18 by 2, right?
Yes, sir.
To get R alone. What property is that? What property did we use to do that? Huh?
Division.
Division. Yeah, exactly. The division property of equality, because we did it on both sides, right? So it's SADMAT, right? And then we're learning in geometry the different properties that we need to use in order to prove our steps. And so, yeah, the division property of equality. And so right here I get 9 inches equals R, okay? And so that's where I'm coming up with my 9, okay? 9 cubed here is coming from how I derived R, okay? So what am I doing when I'm plugging it in? What's that called again? When you plug it in?
Substitution.
Substitution, yeah. So we did that just right here, and now we're doing it again. Substitution, okay? And then you just simplify, right? Now the way I want to simplify it is keeping it in terms of pi, because that gives you the real number, the exact number. And in physics, we use the exact number until we calculate the approximate number, okay? All right, so in this case, I'm going to take 9 and I'll cube it. So what is 9 cubed? It's going to be pretty big, right? So 9 times 9 is 81. And another 9, I forget. I used to know it. I'm not even going to try. So 81 times 9, 729. Okay, so we got 729 times 4. Or can we reduce it? Does 3 go into 9?
Yeah.
Yeah, so it goes into 729, right? So I'm going to take that 729 and I'm going to divide the 3, right? I'm going to take out that 3. So I'll divide 729 by 3. I get 243. So I get 4 pi times 243, which is still 3, right? To the, well, instead of 2 times 3 is 6. So instead of 3 to the 6th power, it's actually 3 to the 5th power, right? But we're going to take this number now and multiply it by 4, okay? It's all simplifying. So we simplify some more, and we simplify a little bit more. So 243 times 4, and that's 972. So it's 972 pi, okay? And that's the volume of our head. So we'll put a little h next to that, okay? The volume of our head, okay? And so that's the first, what is our volume? Okay? So that's your first answer. Now, I always want 2 answers, right? So what's our next step on this one? I would actually plug in pi, so hit the pi button, say times pi, right? And then it's going to give us our approximate, right? So this next step is approximating. So it's going to be v sub h, but it's going to give us an approximate number. So times pi, where's my pi? There it is, equals. So I got 3,053.628,059. And it's really important to use every number that's on there. Okay? Every number that's on there we want to use to get our best approximate value. Alright? Then we want to think, okay, what about ounces? How can I figure out how many ounces there are? Right? So, if this is cubic inches, right? Because we talked about this is inches, right? And so this is inches cubed. Sorry about that. Inches cubed. This is inches cubed, right? So we got to figure out, well, what is a cubic inch? How do we figure out how many milliliters there are in a cubic inch? So we kind of need to know that rule, right? Forgot about that one. So, how many milliliters in a cubic inch?
To convert from cubic inch to milliliters, multiply the volume value by 16.387.
Okay, so 1 cubic inch is equal to 16.387 milliliters. Okay? So in that case, I'm going to take this number and multiply it by that. Okay? So all I'm doing is taking that number that we found for our volume, right? And I'm going to multiply it by this conversion from cubic inches into milliliters, right? How many knew that milliliters was a volumetric unit, right? That we use it a lot for inches to milliliters, tons, okay? So cubic feet, cubic inches, anything that we're talking about in volume, we also love to talk about in milliliters, okay? So, I take that number, multiply it by 16.387, and I get, let's change the color. So, we take 3,053 point ... and we multiply it by 16 point ... right? And what happens is it gets transformed into 50,000 39.80301 milliliters. Okay? So in essence, this is cubic inches, right? And this is milliliters per cubic inches. And that's why these are being canceled right there. And that's why what's left over is just your milliliters. And so now we know how many ounces there are. No, not yet. Darn it. Oh man. So close. So how do I find out how many ounces there are? There you go. So how many ounces are in the milliliter? Why do you think I chose milliliters, by the way?
Because ounces go into milliliters?
Yes. And how did we measure our water?
Milliliters?
Yeah, I didn't measure it in ounces. I measured it in milliliters. So this is going to help me figure out, right? If I know the volume of our sphere, right? Then I'll know the volume of my other sphere. And that's what we also have to do. We have to do the volume of the snowball. We haven't even done that one yet. In order to figure out the density of the snowman. 2 minutes. That's it. Okay. So how many milliliters are in an ounce? Anybody? Somebody? One buddy? Oh, I know somebody who knows. How many milliliters are in an ounce, or how many ounces are in a milliliter? Which one?
How many ounces are in a milliliter? Milliliters are bigger.
Here's a summary from traditional oven. The answer is the change of 1 FLOS unit for volume and capacity measure equals into 29.57 ml.
So 29.57 mLs per ounce, right? That's for 1 ounce, right? Now when we switched from inches to milliliters, right? So for every inch there was this many. So in this case I actually do want to change. I want to think, well, how many milliliters are in an ounce? Does that make sense? Or actually, how many ounces are in a milliliter? That's what I want. So how many ounces are in 1 milliliter?
According to AskNumbers.com,
Ooh, that's a
1
nasty
milliliter
number.
is equal to 0.03381402265 fluid ounce.
All right, so it tells us that 1 milliliter, right? One of these pieces, right, is equal to. Sorry about this. 0.03381402265 ounces. Okay? So I'm going to take that number, right? This number that we just figured out, we're going to multiply it by the milliliters. Okay? So let's multiply it by the milliliters. We're out of time. Next time on the Dan Show, we're going to bring to you an exact answer for this. Actually, let's just do it real quick and then we'll be good to go. Oh, shoot. I'll have to plug this number in. 50039.8030 times.
You forgot the one.
Thank you. 1 times 0.03381 4022 65 equals. All right, we have 1692.047032 ounces. Okay? So that's how many ounces. Oops, sorry. That's how many ounces are in there. So approximately how many ounces? 16 92. Okay? Now we're not going to use this number to calculate, we'll use this one. Fair enough? And that's a start, just to let you know, to be able to calculate gallons of water, right, we're going to have to figure out the density of our snow. Because every snow's different. And that's why we melted our snowball. So in the next session, I'm going to go over exactly how we're going to figure out the density of our snow, right? And then that's going to tell us how much our snowman would have weighed after a few calculations. Right? See ya? No? Yeah?
Period.
Period. It's over. Go to lunch.